NASA has stopped talking. On March 18, 2025, the Gemini Observatory detected something near Comet 3I/Atlas. Something that shouldn't be there. Multiple objects, moving in formation, traveling alongside an interstellar visitor from beyond our solar system. And then, silence. No press releases, no updates, just encrypted data transfers and closed-door meetings. What did Gemini see? And why won't anyone talk about it? This is the story of the silence that followed. Let's go back to the beginning. December 2024. The Atlas Survey Telescope in Hawaii picks up something unusual. A faint smudge of light, moving fast, too fast. They named it 3I/Atlas. The 3I stands for Third Interstellar Object. This wasn't from our neighborhood. Its trajectory showed it came from somewhere beyond the solar system. From the space between stars. Only two other objects like this have ever been confirmed. First was Oumuamua in 2017. Cigar-shaped. Tumbling. Accelerating in ways we couldn't fully explain. Then Borisov in 2019. A comet. More normal. But still a visitor from another star system. Now 3I/Atlas. The third messenger from the cosmic dark. But this one would be different. Because this time, we were watching closely. And we saw something that changed everything. March 18, 2025. 3:47 a.m. Hawaiian time. The Gemini North telescope locks onto 3I/Atlas. It's approaching perihelion. Its closest point to the Sun. This is when comets wake up. When they become most active. The imaging sequence begins. Dr. Sarah Chin is monitoring the feed from the control room. She's done this hundreds of times. Routine observation. Collect the data. Measure the brightness. Track the path. But then she sees it. Multiple point sources. Not one object. Several. Arranged around the main comet nucleus. She runs the calibration again. Checks for optical artifacts. Scattered light. Cosmic ray hits. Anything. The points remain. And they're moving. Not randomly. Not chaotically. In formation. She calls the senior astronomer. Within an hour, the observation is classified as priority alert. By morning, NASA has been notified. But what happened next shocked everyone. The raw images were uploaded to the secure network. Preliminary analysis showed at least 4 distinct objects. Each one reflecting sunlight. Each one maintaining relative position to the comet. Some were ahead of it. Some behind. One appeared to be moving perpendicular to the comet's path. The distance between them? Roughly 50,000 kilometers. About 4 times the diameter of Earth. This wasn't debris. Debris doesn't move like that. Debris spreads out. Scatters. Follows predictable physics. This looked coordinated. Here's where things get strange. On March 19th, NASA issues a brief statement. Additional observations of 3I/Atlas are being analyzed. Further updates pending data verification. And then? Nothing. The daily updates stop. The public data releases pause. Amateur astronomers trying to track the comet find their observation requests denied. No press conference. No interviews. Just silence. Now, let's be clear. This isn't necessarily sinister. Space agencies are careful. When you detect something unusual, you verify. You check your instruments. You rule out errors. You don't want to announce a discovery only to retract it later. Remember the faster-than-light neutrinos? Turned out to be a loose cable. So the silence could be standard procedure. Caution. Due diligence. But here's what made people nervous. The European Space Agency went quiet too. JAXA in Japan stopped publishing orbital updates. Even private observatories that usually share data openly started marking their findings as under review. It was coordinated silence. Global. Synchronized. And in the age of social media and instant information, silence is loud. Astronomers on forums started asking questions. Where did the data go? Why can't we see the raw images? What happened to the follow-up observations? The speculation began. And the longer the silence lasted, the wilder it became. But before we dive into theories, we need to understand what made 3I/Atlas strange from the very beginning. Let's look at the facts first. Then we'll explore the speculation. and we'll be clear about which is which. Fact number 1. 3I/Atlas is a comet. It has a coma, a tail. It's outgassing as it approaches the Sun. This is confirmed. Fact number 2. Multiple objects were detected in proximity to it. This is also confirmed by independent observations. Now here's where it gets interesting. Theory 1. Natural fragmentation. Comets can break apart. We've seen it before. Comet Shoemaker-Levy 9 shattered into pieces before hitting Jupiter. Comet Linear disintegrated in 2000. Maybe 3I/Atlas is fragmenting. Maybe those objects are pieces of the original nucleus. This is the most likely explanation. It's natural. It follows known physics. But there are problems with this theory. Fragments spread out randomly. They don't maintain formation. They don't move in coordinated patterns. And they certainly don't position themselves at specific distances from each other. Computer models show that comet fragments should disperse rapidly. Within days, they'd be scattered across thousands of kilometers with no discernible pattern. What Gemini detected didn't look like that. Theory 2. Captured objects. Maybe 3I/Atlas picked up hitchhikers. Small asteroids. Dust particles. Material it gravitationally captured during its journey. But here's the problem. The escape velocity of a comet nucleus is tiny. We're talking meters per second. Anything captured would be moving extremely slowly relative to the comet. These objects were moving independently, at speeds that suggest propulsion or momentum separate from the comet itself. This doesn't fit captured material. Now we enter speculation territory. We're being honest about that. Speculation 1. Engineered formation. What if these objects aren't natural? What if they're observing the comet? Studying it? This is the hypothesis that caused NASA's silence to feel so heavy. Could an advanced civilization send probes to study interstellar objects? Absolutely. We've thought about doing it ourselves. The Breakthrough Starshot initiative wants to send tiny probes to Alpha Centauri using laser propulsion. If we can imagine it, maybe others have done it. But let's be scientific. Extraordinary claims require extraordinary evidence. And right now, we don't have that evidence. We have anomalous data, unexplained patterns, but not proof. Speculation 2. Natural but unknown phenomenon. Maybe we're seeing something that exists in nature but we've never observed before. Some kind of plasma formation. Electromagnetic interaction with the solar wind. A quirk of how interstellar objects behave when entering a new star system. The universe has surprised us before. Black holes. Dark energy. Fast radio bursts. All of these seemed impossible until we found them. Maybe 3I/Atlas is showing us something new about cosmic physics. But there's another mystery. One that's purely scientific but equally baffling. The green anomaly. When comets approach the sun, they glow. The heat vaporizes ices, creates a coma of gas and dust. And that gas emits specific colors based on its chemistry. Most comets show a signature from diatomic carbon, C2. It creates a distinctive green glow around the nucleus. 3I/Atlas glows green. But when scientists analyzed the spectrum, something was missing. The C2 signature. It wasn't there. The comet glows green without the molecule that makes comets green. Dr. James Morton from the Harvard-Smithsonian Center called it the most puzzling spectroscopic result I've seen in 20 years. So what's creating the green light? Initial theories suggested exotic molecules. Carbon chains that don't form in our solar system. Chemistry that happens only in interstellar space. But follow-up observations were needed to confirm this. Those observations were scheduled for April. But April came, and the data never appeared. Because by April, 3I/Atlas had moved into a position that made observation impossible. Orbital mechanics are unforgiving. As 3I/Atlas continued its path, it moved behind the Sun from Earth's perspective. Solar conjunction. The Sun's glare blocked all observation. For 6 weeks, no telescope on Earth could see it. April, May, early June. No new images. No spectroscopy. No way to track those mysterious companion objects. Just silence. And waiting. This is where the conspiracy theories exploded. People asked, how convenient that it disappeared right when we needed to study it most. But this isn't convenience. It's orbital mechanics. It's predictable. It's geometry. The blackout window was known in advance. Astronomers had planned for it. They front-loaded their observations in March, hoping to collect enough data before the sun blocked their view. But the Gemini detection happened late in that window, only days before conjunction. By the time the data was verified, analyzed, and follow-up observations planned, 3I/Atlas was gone. Behind the sun. In the cosmic shadow. And all anyone could do was wait for December. December 2025. That's when 3I/Atlas will reappear. By then, it'll be moving away from the sun heading back toward interstellar space. This is our last chance to study it before it disappears forever into the dark between stars. Every major telescope is already booked. Hubble. James Webb. The Very Large Telescope. Subaru. Keck. They're planning spectroscopy. High-resolution imaging. Polarimetry. Every tool we have will be pointed at this object. Here's what scientists are looking for. Are those companion objects still there? Have they changed position? Are there more of them or fewer? What is creating that green glow? Can we identify the molecules? Is there any radio emission? Any infrared signature that doesn't fit natural comet activity? And perhaps most importantly, how do those objects move? If they're fragments, they should be drifting apart. Spreading out? Following ballistic trajectories. If there's something else, they might maintain formation. Adjust their positions. Show signs of active navigation. That's the test. That's how we'll know. Nature is elegant but chaotic. Engineering is precise but detectable. December will give us the answer. Or at least it should. The real question is whether we'll be told what's found. There's something profound about silence. For most of human history, the universe was silent to us. We looked up at points of light and wondered. We told stories. We built myths. Then we built telescopes. And the universe started speaking. We heard pulsars ticking like cosmic clocks. We saw galaxies colliding in slow-motion ballet. We detected gravitational waves, ripples in space-time itself. The silence broke. And the cosmos became loud with data. But now, with 3I/Atlas, we face a different kind of silence. Not the silence of an empty universe, but the silence of information withheld. Questions unanswered. Data locked behind closed doors. Maybe there's a good reason. Maybe scientists are being careful. Verifying. Ensuring they don't mislead us. Or maybe they saw something that changed everything. Something that requires time to understand. To contextualize. To explain. We'll know in December. Until then, 3I/Atlas moves through the dark. Silent. Mysterious. Carrying its secrets. And we're here. On this small world. Looking up. Waiting. Because that's what we do. We're curious. We question. We explore. The universe doesn't owe us answers. But we'll keep asking anyway. This is Cosmic Pulse. And the story isn't over.